Hi, I'm Ms. Hall, and in this video, we're going to review solving a system of equations by elimination. Let's just remind ourselves what a system of equation is. A system of equations is two or more equations that represent the constraints in the same situation. They form a system of equations. I've got three pairs here. Our curriculum likes to use this fancy curly brace to show you that these are related systems. Now, I put down here, there are three main methods for solving a system of equations. There is by graphing, where you graph the two systems and the solution is where they intersect. There is by substitution, and that is where you replace one variable with the expression it is equal to, with its equivalent. So you could see this video is not going to be about substitution, it's going to be about elimination. An elimination is a method of solving a system of two equations and two variables where you add or subtract a multiple of one equation to another in order to get an equation with only one variable, thus eliminating. I'm not going to spend too much time on that because we've got some examples to get to. Let's go here. Okay, so our goal in elimination is to eliminate a variable. So we're going to try to identify a variable that will be easy to eliminate with addition or subtraction. I see the coefficients of the x term are opposites. We've got a positive 4 and a negative 4, so those will be able to eliminate if I add these equations together. I like to put a big plus sign and circle it so I don't get confused that maybe the first term is positive that I'm adding. And then we go through and we add these equations. So that eliminates the x's. 3y plus 5y is 8y equals 10 plus 6 is 16. So you can see that we've eliminated the x's. That's why it's called elimination. And we've got now we can finish solving this equation. We're going to get y by itself by dividing both sides by 8. And we get that y equals 2. In a system of equations, there are two variables, so we're looking for the value of two variables. So now we're going to pick one of the original equations. I like to start with the easier one. For me, it looks like the top one because there's no negatives in it. So we have 4x plus 3 times y equals 10, and we have a value for y, so I'm going to plug that in and then solve. Let's see if this pen keeps going. 4x plus 6 equals 10. And then I'll subtract 6 from both sides. Get 4x equals 4. Divide both sides by 4 and get x equals 1. I'm going to go ahead and write my solution as an ordered pair. So let's write it as 1, 2, because an ordered pair is our x and then our y. I have queued up for me as well. Let's see how well this translates. In Desmos, so I've got the Desmos app on my phone, we could also check our answer by graphing these two equations. You see the first two equations I put in are for this problem. I'm going to click there. And then we could use Desmos to help us find the point of intersection. And there it is, 1, 2, which is the answer. So this is how we would solve it by graphing, and it's just a way to check that we got the right answer. Let's do this process again. We're going to start by identifying a variable that we can eliminate. Now I see the 8's here, but they're both positive, so adding them together would not eliminate. I'd get 16 x's. So in this case, I'm going to subtract my equations. And then the 8's go away, and then I have 10y minus 1y is, 11y minus 1y is 10y equals 37 minus 7 is 30. You need to make sure that you subtract everything. Don't just suddenly add this for some reason. I see that happen a lot. Then we'll divide both sides by 10. We'll get y equals 3. I will pick an equation to plug it back into. Let's go. This one, the terms are smaller. So we have 8x plus 1y, and y is 3. equals 7. So we'll subtract 3 from both sides to get the x by itself. And we have 8x equals 4. Divide both sides by 8, and we get x equals 1/2. Let's write that as an ordered pair. We have 1/2, comma, 3. Those are x and y. And I'm going to pull back up my Desmos app to check this. So in Desmos, I can click that to unshow those graphs. And now I want to show these two graphs, right? Those are my original two equations here. And I can go in, click on the point of intersection, 0.5 and 3, and that's exactly what I got. Great. Last one. I'm going to ask you to try it on your own and then unpause the video when you're ready to check your answer. Here we're going to eliminate the y's. So there's each a 1 in front of these y's. So if I add these equations together, it will eliminate the y's. We have 3x equals 15. Divide both sides by 3. X equals 5. And then using either equation, let's see, I'll do the top one that has the plus signs. I'm less likely to mess that up. 2 times the x value that I just got of 5 plus y equals 4. 10 plus y equals 4. Subtract 10 from both sides, and I get y equals -6. Therefore, my answer is 5, -6. And you guessed it, I am going to take out Desmos one last time. It is a helpful tool for me to use to see if I got the right work. I have plugged in both equations. I will turn them on, and I will look for the point of intersection. There it is. Let me zoom in a little bit and then click. The point of intersection is 5, -6, and that is exactly what I got.